So hello, it's me again. All right, and this is going to be one of two little videos we're going to have about solving exponential word problems. Okay, if you'll recall, an exponential function is one that looks like y is equal to a times b to the x. And if you think back, we did an activity in class where we worked with the rice grains on a board. And we worked with the decay of an exponential function, right? Of a radioactive material. I mean, the decay of a radioactive material, right? And in this formula, if this was a growth function that represented the growth of, say, the rice grains on the board. If you'll recall, our peasant had, I think it was 3 grains of rice to start, right? And each one was doubled, right? So each space after that was doubled. So the first space was 3 grains, the second space was 6, and then the third space was 12, and then 24, and so on. And we ended up, after working with that, we ended up with a function that looked like this, where y was equal to 3 times 2 to the x, right? And then we had, and in this formula here, 3, that was the initial amount. So if we'd started out with 10 rice grains, there would be a 10 there instead of 3. And then the 2, which was the exponential base, that was the multiplier, or really the growth rate. It was doubling, right? And then x, and we could have used t or something like that to represent time. X, in this case, was the number of spaces, and represented more or less the amount of time or the amount of distance over which the rice function grew. Okay, so that's kind of our basic notion here of a growth function. Then our decay function for the radioactive element looked like this. It's very similar. Right? Where again, oopsie, that wasn't quite right, was it? Here, I'm going to neaten that up a little bit. I'm going to do this neatly. It was 100 times 1/2 to the x, because again, here, 100, that was the initial amount. And then, as you can see here, 1/2 was the multiplier, and this was the growth rate, but really the rate was a fraction because the amount of radioactive element was decaying. And then x was, again, you know, that was the amount, in this case, the amount of time over which the element decayed, right? So they all have the same amount, the same parts to them, really. Right? So it turns out that another version of this formula is called, if you're working with money, is something called the compound interest formula. Okay? And the compound interest formula looks like this. A is equal to P times 1 plus r to the t. Now this represents the growth of money over time, and 1 plus r is the same, works out to be the same multiplier as 2, or the same multiplier as 1/2. P is, if we're talking about money, P is an initial amount of money. Okay, so let's kind of define our terms for this formula. Okay, P is the principal. That's the initial amount of money. Now I know that this may not seem clear right now, but give it a minute and it'll all be totally clear. R is equal to the annual percentage rate. Usually abbreviated the APR, or in capital letters, the APR. Okay? And then T is always going to be the number of years. Okay? For these kinds of problems. So let's say we've got this problem here. I've got a savings account. Right? And in the savings account, I have $100 to start with. Okay? And let's say that I happen to know that the terms of the savings account are that the annual percentage rate, the APR, is equal to 2%. That means at the end of every year, or rather at the beginning of every new year, they add 2% of what was in the account the previous year. And so every year the account grows by 2%. Okay? Now the question is going to be, here's our problem. How much money will be in the account after 2 years? And let's say also after 4 years. Okay? So that's going to be the problem that we're going to solve right here. And I suppose it might spill over to the next page, but I hope not. So let's do the 2-year one right here. So in this case, for our problem up here, notice instead of x, I used t. But t is like the x in these, is like the x variable in these compound interest problems. So we're going to use this formula, and we're going to plug the numbers that we've been given here into the formula and solve for A, the amount of money after the given number of years. For the first one, it'll be 2. So for this one, for 2 years, what we mean is that T is going to be 2. So the number of years is going to be 2. The principal I'm giving you is $100. The amount of money that the annual percentage rate R is 2%. For these problems, we always write that percent number in decimal form. Do not put just plain 2 in for R, or you'll actually be finding 300%. You'll be talking about an annual growth rate of 300%. So that's not what we're actually 200%, which is not what we want. For decimals, remember, if we start with a decimal of 2, we have to move the decimal point 2 places over. 1, 2, like that. And so that decimal rate is 0.02. All right? Okay. So anyway, so now we plug 0.02 in for T. We plug 100 in. I'm sorry, 0.02 goes in for R, the annual percentage rate. 100 goes in for P, and then 2, the amount of time, goes in for T. So this is 200. This is going to be 100 times 1 plus 0.02 to the 2, right? And that's equal to, if we simplify the 1 plus 1.02, that's 100, 1.02 to the squared, to the second power. Now you can see here that again, now that we've simplified the inside the parentheses, this looks like our exponential growth rate, where instead of 2, we've got 1.02, right? And 2 is the x number, the amount of time, and 100, that's the initial amount, right? So it's the same kind of function. Now Mr. Calculator tells us, I'm dragging out Mr. Calculator, be very sure that you follow the correct order of operations on this. Do the exponential part first and then multiply. So on Mr. Calculator, I'm doing 1.02 exponent 2 is equal to that. 1.04. Now so that's going to be rounded off. Then I'm not going to round that off. I'm just going to straight away multiply that by 100, and that's going to be equal to $104.04. See that? 104.04. So that means this is $104.04. So after 2 years, that's how much we would have. Okay, so I'm going to go to the next. So this, by the way, here is example 1, okay, which is the 2-year one. Example 2, we're going to do it again, but for 4 years, right? So we're going to use the same formula. Okay, A is equal to 100 times 1.02, okay, and to the t, I'll put t there first. But for the second version of the problem, we wanted t is equal to 4 years. Now, if I'm going fast here, do not hesitate to rewind and watch what I did again. I'm going to put 4 in for the t. It's 100, 1.04 to the 4th power. Again, I drag out Mr. Calculator and I do 1.02. Now I do exponent 4. And you see here 1.08 and so on. I'm not going to round that off. I'm just going to hit right away multiplication times 100. Remember, on these problems, exponent first, then multiplication equals to that. And then round it off to the nearest cent, that's $108.24. Can you guys see that? That's second decimal place there. So this is going to be $108.24. So after 4 years, that's how much money we would have if we started with $100 and it was growing by 2% per year, which is actually on the high end for savings accounts these days. And so, yeah, if you intend to have your money grow at any particular fast rate, you can see here that it takes a while for the money to grow if it's in a savings account. Okay, so that's a couple of those. Now now let's do another one. And I'm going to give you, let's do another one like that, and then I'm going to give you one to try out. Okay, so let's see. What if okay, so this is going to be example, that was example 2. Here's going to be example 3. Okay, what if we begin with, the principal is going to be $350, let's say. And let's say the annual percentage rate, the APR, which in our formula is just R, let's say that that's 1.75%, as it often is given as some kind of a decimal. How much money will be in the account? How much money after 10 years? So leave it in for 10 years and see what happens. Well, we're still using this formula that the principal, rather the amount of money, is equal to P times 1 plus R to the T power. Okay, well, keep in mind when I said 10 years, that's what T was going to be equal to. R is 1.75. And the APR, and then the principal is 350. Now, first off, before we plunk numbers into the formula, that has to be changed to decimal form. So I'm going to do that here. 1.75, right? I move the decimal point 2 places, and that gives me 0.0175. That's the number that we're going to put in for R. Right? So A is equal to 350 times 1 plus 0.17 1.0175, okay, to the t power, but t is equal to 10, so I'm just going to write 10 in, right? And so you can see right off that gives us the the amount is 350 times 1.0175 to the 10th power. And again, we drag out Mr. Calculadora, and it's going to be 1.0175 exponent 10, right? And then times 350 is equal to 400, rounded off to the second decimal place, to the 100th place, $416.31 after 10 years. Very good. Okay, so now, same scenario. I would like you to tell me how much would be in the account after, let's say, t was equal to 6 years. And what if after t was equal to, oh, I don't know, 3.5 years? So that t was 3.5. Okay, so this will be for you try. Okay, and then, okay, so this is going to be you try number 1, then number 2. Let me give you one here. Let's say that the initial principal is equal to $4,000, right? And let's say that the APR, the annual percentage rate, is going to be, say, 4%. Okay, how much money would be in the account after 6 years? How much after 6 years? Okay, so you go ahead and try those out. Okay, put the video on pause right now, and you go ahead and try some of those out. Okay, very good. Okay, you're back. Okay, so the you try number 1 goes like this. So it's going to be 350 times, and it's going to be, we had 1.0175, and it's going to be to the 6th power this time because it was supposed to be after 6 years. So 1.0175 exponent 6, do it on the calculator here, of course, and then times 350, that's equal to, and I'm getting here after 6 years, rounded off to the 10th place, $350.40. If it was 3.5 years, okay, I would just go ahead and type in 3.5 for this, so it's going to be 350, 1.0175 to the 3.5. Okay, calculator work, and then times 350 is equal to $371 and 91 cents. Okay, all right, now the second example is going to be, what if, the principal was $4,000, or your second, so we put $4,000 in for the principal, right? The APR was 4%, so that means we're going to use, R is going to be 0.04, because we moved the decimal point 2 places, and we want to know T is going to be 6 years, so we just plunk the numbers in, times, that's going to be 1.06, because it's, 1.04, because that's 1 plus 0.04 on the inside there, right? And then to the 6th power, so 1.04 exponent 6 times 4,000. And that is, after 6 years, you've got $5,061.28. Okay, very good. Now, the second half of this is using logarithms, because we could have done those problems before. We were just plunking the numbers into an exponential function and cranking away on them until the answers fall out the bottom. But, you know, a more realistic problem might be one like this. Let's say that, and here's an example. Let's say that I need for an investment, let's say that I want to know, I need in hand $10,000. Okay, maybe for a college fund, let's say, or maybe say to save up to buy a house, or maybe to save up to buy a car or something. But I'm going to need $10,000 cash. Now, as it happens, right now, I've got, let's say, current balance, current amount. What I've got right now is $6,000. Okay, it's the total that I've got right now. Okay, so I've got an investment opportunity. Okay, let's say it's an investment that gives me an annual percentage rate of 10%. The annual growth rate is, for some reason, guaranteed to be 10%. Annual growth rate or annual percentage rate means that every year the amount will increase 10% over what it was the year before, right? So I've got 10% and I've got $6,000, okay? Now the question is, how long will it take that investment to go from $6,000 to $10,000, right? So it's the opposite problem we just did. Up here you're given the time, and we just cranked through the exponential function to figure out what the ending balance is. Here, we're going to do the problem the other way around. I've given you the ending balance, right? We want to go and figure out how much time will it take in order to solve for, in order for that to happen, in order for it to grow for that. Well, we're going to use the same formula, okay? A is equal to P times 1 plus R to the T power. We're using the same formula because it's the same situation. It's just that instead of solving for A, instead of being given T and solving for A, we're going to be given A and we're going to be solving for T. Okay? So we're going to set up the formula the same way. So $10,000, so I'm going to write out, make sure we've got this fair and square here. $10,000, that's the amount we want to end up with. Our current amount, which we're going to call P, the amount we've got right now, that's $6,000. And R is 10%, which we write in decimal form to be 0.10, after we move the decimal point over 2 places, right? Okay, so now we plunk the numbers, these numbers, into the equation. A is 10,000. P is 6,000, and it's going to be 1 plus 0.1 to the T power. We don't know T. That's what we're solving for. Okay. So that's going to be 10,000 equals to 6,000 times 1.1 to the T. Now, that's an exponential equation, and we're going to use logarithms to solve it. Okay? The first thing to do, we're going to use the same procedure we learned last time. We're going to isolate the exponential part by dividing both sides by 6,000. Right? Over here, 10,000 divided by 6,000, that's equal to 1 point, rounded off, about 1.7 because it's actually 1.6666. So we're going to call that 1.7, and that's equal to 1.1 to the t power. If you remember what we did last time, we logged both sides in order to spring the t out of the exponent. So that's going to be log this side. Actually, what I'll do is I'll put another version over here. Log now of 1.7 is equal to log of 1.1 to the t power. Now remember, that t swings out front. So now we've got log 1.7 is equal to t times log 1.1. So now we're kind of putting it all in now, so we've got t times, I'll turn the terms around so we can see the exponent or the variable in front. We've got t in front. Now to get t by itself, we're going to divide both sides by whatever log 1.1 is. Now that last little bit t, the number of years, is log 1.7 divided by log 1.1. I just do that on Mr. Calculator here, okay? Log, and notice I'm using base 10 log here. It doesn't matter which log you use. Log 1.1. Make sure you close the parentheses there, or however you need to do to group it on your calculator, divided by log, oopsie, I did that backwards. Log 1.7, close that, divided by log 1.1. And round it off. Let's round this year off to the 10th place. That's about 5.6. So in other words, t would be about equal to about 5.6 years under the conditions given to grow from $6,000 to $10,000. Okay? All right. Now, this is getting kind of long. I'm going to try one more example here, and then I'm going to post some classwork problems for you guys to do. Okay? And in order to practice this, okay, it's not that hard, but you do need to practice a few so that you can see how it works. Okay, so let's say that I've got $1,000 in my account. Okay, that's what I've got right now. So that's the principal. I want it to grow to $5,000, right? And let's say that the annual percentage rate, the APR, is equal to 5.6%. Okay? And we want to know how many years will it take in order for $1,000 to grow to $5,000. So we're using the same formula we were just using. Okay? P times 1 plus r to the t. Okay, this is put in decimal form, so I move the decimal point over 2 places, so it's 0.056, right? And so that gives us a is equal to 5,000 is equal to a, the 1,000 times 1.056, that's 1 plus r, 1 plus 0.056 to the t. Now we're going to divide. Now we're going to solve this. First we divide to get rid of the multiplier. Don't add, don't subtract, don't multiply. We're multiplying here. So we divide to cancel out that one, to cancel out the multiplication by 1,000. And that gives us, over here, we're seeing 5, right, is equal to 1.06 to the t, right? Now we log both sides to solve the exponential equation, right? Mr. T swings out front. So log 5 is equal to t times log 1.06, right? So now, so that's t times log 1.06 is equal to log 5. So we divide both sides, as you can see here, by whatever log 1.06 is. All right? So t is equal to whatever those work out to be, log 5 divided by log 1.06. And that works out to be, and you're going to love this number, you should try it yourself, 27.6. So that means it would take 27.6 years for that money to grow from $1,000 to $5,000 under these conditions of an annual percent rate of 5.6%. Okay, so hopefully that's going to be enough to get on with, all right? And I haven't numbered these examples, but this is about example number 4, I think. After this, I'm going to post some classwork problems for you to look at, and you should try those out, and then the homework will be a little bit after that. All right, very good. Thank you.